This is the video for the second day for section 13-3 in accelerated geometry. And today we are going to be talking about, rather than dividing rational expressions, we are going to be talking about complex fractions. A complex fraction is a fraction that contains one or more fractions in its denominator, its numerator, or possibly in both. One example would be 1 over x plus 2. So in the big fraction, the numerator is 1 and the denominator is x over x plus 2. So it's like a fraction within a fraction. Or an example of it just being in the numerator might be x minus 3 over x plus 4 all over 7. Or what if we had x minus 3 over x plus 4 all over x plus 2. Now, you would absolutely never write a final answer in complex fraction form like this, with fractions within fractions. So the easiest way to simplify a complex fraction is to remember that really a fraction bar, like one of these lines here, is just the same as saying dividing. So for example, this last complex fraction could really just be written as x minus 3 over x plus 4 divided by x over x plus 2. And that turns it into a dividing rational expressions problem, just like the video that you watched the day before. So let's look at an example here then. What if I had x plus 2 over x minus 1 all over x minus 3 over x plus 5? So to simplify that complex fraction, the first thing that I would want to do is actually separate it into the numerator fraction divided by the denominator fraction. And at this point, just like I said a minute ago, this is just like the problems we worked yesterday. So remember, to divide by a fraction is to multiply by its reciprocal. So I would take that second fraction and I would flip it over to get the reciprocal. So this would become x minus 2 over x minus 1 times x plus 5 over x minus 3. So then your numerator becomes x minus 2 times x plus 5, and your denominator becomes x minus 1 times x minus 3. And you can very easily look at that and tell that there are no common factors that can be canceled out between the numerator and the denominator. So now you're just going to FOIL out the numerator and get x squared plus 3x minus 10, and FOIL out the denominator and get x squared minus 4x plus 3. There you go. There's your answer. And if you were asked to give domain restrictions, well, it says assume that all expressions are defined, so we don't have to worry about domain restrictions on a problem like that. Okay? All right, so let's try another one then. It really is that easy. So this one, we have a little bit more work to do. We have 3 over x plus x over 2 in the numerator, all over x minus 1 over x in the denominator. So what I'm going to do first is I'm actually going to simplify my numerator. So I'm going to focus just on this for the time being. If I had just given you 3 over x plus x over 2 and told you to simplify that, then you would start by finding a common denominator, which is 2x. So the first fraction is missing the 2 in the denominator. So both the numerator and the denominator get multiplied by 2. So that would turn the numerator into a 6. And then in the second fraction, we're missing x's in the denominator. So when we multiply the numerator and the denominator by that, we get x squared in the numerator. So now that fraction is 6 plus x squared over 2x. So my problem now is 6 plus x squared over 2x all over x minus 1 over x. I can go back to the beginning and pay attention to the whole problem now. So at this, that can be pulled apart into 6 plus x squared over 2x divided by x minus 1 over x, which, remember, is just multiplying by the reciprocal of that second fraction. So 6 plus x squared over 2x times x over x minus 1. Now, if you look at that, you should notice that you now have a common factor here. You can take an x out of both the numerator and the denominator. So that leaves you with 6 plus x squared in the numerator and 2 times x minus 1 in the denominator. So I can distribute that denominator through, and I get 6 plus x squared over 2x minus 2, which is a perfectly acceptable answer. Now, if any of you, it's just kind of bothering you that that numerator is not in standard form, you can just rearrange it and write it as x squared plus 6 over 2x minus 2. Okay, so I want you to give one a try. I want you to give number 3 a try here. So pause your video, take a few minutes, and see if you can get this complex fraction simplified all the way. Okay, so let's see if you got it as simplified as I did. I got 1 over x for my final answer. So let's talk our way through that. You should have hopefully pulled the complex fraction apart into x plus 1 over x squared minus 1 divided by x over x minus 1. Then you would multiply by the reciprocal of that second fraction, so it would become x minus 1 over x. But before I start multiplying, hopefully you realized that x squared minus 1 is factorable. So I factored it to x plus 1 times x minus 1 because it's a difference of 2 squares. So now look at all the common factors I have. I have an x plus 1 in the top and the bottom, and I have an x minus 1 in the top and in the bottom. So if you look across all the numerators now, there's nothing left there, but it can't just disappear. So it becomes a 1. And if you look across all the denominators, the only thing left is an x. So final answer, 1 over x. If you got that one right, give yourself a big pat on the back because that was a good one. All right, now I want you to pause the video again and take a few minutes and solve number 4 here. Okay, so hopefully you started with just the numerator by adding those two fractions together. Your common denominator would be 2 plus x, and when you add those together, you should get 3 over 2x for your numerator. So now your complex fraction is 3 over 2x all over x plus 4 over x minus 2. So I went ahead and I skipped that whole writing it as the division step, and I went ahead and just put that I was multiplying by the reciprocal of the denominator. It is perfectly acceptable for you to skip that division step too, as long as you remember to write the reciprocal of the denominator down here for your multiplication step. So then notice you don't have any common factors in your numerator and your denominator, so you can just distribute everything out. So 3 over x minus 2 becomes 3x minus 6 in the numerator, and 2x times x plus 4 becomes 2x squared plus 8x. So this should be your final simplified answer. Okay, so since you guys are such super smarties, we're going to try some word problems now with these complex fractions. So this says a hiker averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip when walking uphill. What is the hiker's average speed for the entire trip? Okay, so if you remember, speed is equal to distance divided by time. So if we can manage to figure out the total distance traveled and the total amount of time that it took, we can figure out then what the average speed is. So the distance, well, you're walking uphill and then you're walking the exact same amount, or you're walking downhill and then you're walking the exact same amount uphill. So the distance, I'm just going to call one way up or down the hill d. So the distance then would be 2d because you're going down and then back up. Okay. The time then, the amount of time it takes to walk just one length of the hill, like if this is my hill here, this right here is d, whether I'm walking up or down, okay, for you visual people. So the amount of time, well, to go downhill, it's that distance divided by the rate that you're walking, which when you're walking downhill, it's 1.4 miles per hour. But then you have to add to that the amount of time that it takes you to go uphill. Well, it's the same distance, except it takes you 0.8 miles per hour to do that. So your total time then, I would suggest that we go ahead and add these fractions together before we worry about going back up here to speed. Your total time then, you need a common denominator. I wouldn't try to figure out what these two have in common. I would just multiply the two together and make that be your common denominator. So if you multiply the two of them together, you should get 1.12. Okay? So that would mean that the first fraction would need to be multiplied by 0.8. So this would become 0.8d. And the second fraction would need to be multiplied by 1.4. So this would become 1.4d. So altogether, that becomes 2.2d over 1.12. The reason that I wanted to combine that all into one fraction is because now, when I go to calculate my speed, my total distance is 2d, and my time is 2.2d divided by 1.12. So I don't have these fractions that I'm having to add down here in the denominator now. I've already taken care of that part. So to simplify this complex fraction now, that 2d is like a 2d over 1 times the reciprocal of the denominator fraction, 1.12 over 2.2d. Notice what happens here. I have a d in the numerator and the d in the denominator, so they cancel out. And so 2 times 1.12 is 2.24, and 1 times 2.2 is 2.2. So divide that on your calculator, and you should get 1.02 miles per hour. So this hiker was walking 1.4 miles per hour downhill and 0.8 miles per hour uphill, but the average speed was 1.02 miles per hour. So you cannot just take these two rates and average them together. It does not work that way. You have to use the distance divided by time formula. So with that thought in mind, I want you to pause the video again, and I want to see if you can figure out number 6. Okay, so I used the same thought process as in the hiking problem before. It says that Justin's average speed on his way to school is 40 miles per hour, and his average speed on the way home is 45 miles per hour. We're assuming that he travels the same distance each way. What is Justin's average speed for the entire trip? So since he travels the same distance each way, our total distance is 2d. The time then, well, to get to school, it would be d over 40, because he travels at 40 miles per hour. And to get home from school, it would be d over 45. So the total time would be adding those two fractions together, which means getting a common denominator. And once again, I just multiplied those two things together. I didn't try to mess with least common denominator and all that. So you end up with 85d over 1800. So then your speed is distance divided by total time. So 2d divided by 85d over 1800, multiply by the reciprocal of that denominator, and you get 3600 over 85 miles per hour, or 42.4, since it only said to round to the nearest tenth, 42.4 miles per hour. Okay, so hopefully complex fractions are pretty basic to you. They're just like the dividing rational expressions that we did yesterday. And hopefully these word problems are starting to make sense.